Hi everybody, here we go. 4-2, let's do a little bit of enrichment here for my 8th graders and some basic instruction if you're already in Algebra 1. Negative exponents in the denominator. We're even going to look at negative exponents in the numerator. Note, if you move a numerator to a denominator or a denominator to a numerator, you use the inverse exponent. Example, 2 to the negative third power. As we all know, that really means 2 to the negative third over 1. Normally that's invisible. We don't put whole numbers or any numbers over 1. But it is there. So I add it in. If I want to remove that negative 3 exponent, I move it to the denominator and I make it positive. So I've taken my negative 3, I've moved it down here to my denominator and made it positive. 2 moved to the denominator and the exponent negative 3 became a positive 3. What if my negative exponent was in the denominator to begin with? Well, I'd never ever want negative exponents. So no matter where they are, I have to remove them. So if it's in the denominator, I just take the negative 3 exponent with the 2. I move the entire number up here to my numerator. The exponent negative 3 moved to the numerator along with the 2 and became positive 3. There's no calculation. You just move it and change the sign of the exponent. In this case, I have a negative 5 numerator, k to the negative 4 my denominator. The negative 5 in the numerator is fine. It can stay there. But the k to the negative 4 in the denominator, it cannot stay there. I'm spreading it apart. I'm doing expanded here. This is the same as negative 5 over 1 times 1 over k to the negative 4th. I can leave negative 5 over 1, but 1 over k to the negative 4th has to change to k to the positive 4 in the numerator. Now I can just multiply straight across, and I end up with negative 5 times k to the 4th, which is negative 5 k to the 4th power. You must eliminate negative exponents. The term must be inverted between the numerator and the denominator. Numerators become denominators, denominators become numerators, and exponents become positive. Positive exponents stay where they are. Only the negative exponents flip. Let's try something. Here I'm looking at x to the negative third. We know that has to move to the denominator. 0, a to the 0. Do you remember your rules of exponents when you have an exponent of 0? A to the 0 is then called 1. So it's going to be eliminated. Y to the 5 stays exactly where it's at. My answer, 1 over x to the third, y to the 5th. 4 times x to the negative 6th times y to the 2nd. Think about expanded form and take each piece separately. The 4 is going to stay where it's at, a numerator. X to the negative 6 moves to the denominator and becomes positive. Y to the 2nd stays. So as soon as I see a negative exponent, the first thing I like to do is put my fraction bar in my answer. And then just start rearranging and putting everybody where they belong. I see a negative exponent. The first thing I want to do is put in a fraction bar and then say, where does 2 belong? Numerator. F to the 0, it's going to become 1. It's going to disappear. 7 is going to stay in the denominator. But g to the negative 10, that has to move to the numerator. Eliminate negative exponents, move them to the inverse location, and invert the exponent. Let's just do a few more. T to the negative 4 becomes 1 over t to the positive 4. 3 stays in my numerator. R to the negative 5th moves to the denominator. S to the negative 3 moves to the denominator, while t to the negative 5 moves up to the numerator. H to the 0 equals 1. unless h equals 0, and then it is undefined. That should cover our negative exponents. Go slow when you do negative exponents. Do not rush it. Thank you.